Worksheet 2, number 1. Convert the following numbers to hex. Again, to convert these numbers, you either need to build this chart or have it memorized. If you have it memorized, then you know the answer is 5A here, and you know the answer here is, this is D, and this is B in hexadecimal, base 16. But if you don't have it memorized, you need to build the chart. So this is in binary, and base 16, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. 0, 1, 0, 1 is right here, which is 5. 1, 0, 1, 0, 1, 0, 1, 0 is A. 1, 1, 0, 1, 1, 1, 0, 1, D. 1, 0, 1, 1, 1, 0, 1, 1, B. It's a lot quicker if you have it memorized. So number 2, right, one line of C code to set pins RB1 and RB2 as inputs, and all other as outputs. There's 7 bits, right, and the most significant bit is 7. So we want 7, 6, 5, 4, 3 to be outputs, 2 and 1 to be inputs, and 0 to be an output. And if we want to represent this as binary, 0B, and where it's port B, so it's the trice register, trice B equals 0B, 0, 0, 0, 0, 0, 1, 1, 0. Number 3, if the lower nibble of port A is configured as output and the upper nibble is input, all the port A pins are hooked up to LEDs. How many LEDs will light up after this command? Let me draw the hardware. Let me do this. So this was number 3. All of the port A pins are hooked up to LEDs. If this is our microcontroller here, and we have RA0, let's say they're hooked up like this, so down to RA7, they all have resistors, they're all tied to ground, something like that. And we said the lower nibble is configured as outputs. So these guys are outputs, and these guys are inputs. So if these are inputs, it means these pins are in a high impedance state, which basically disconnects them from the circuit. So if these are all disconnected from the circuit, there's no chance any of these LEDs are going to come on. And then we send the command port A equals 0x3c. So port A equals 0x3c. If we convert this to binary, in binary it would be 0011 1100. Remember, this is the most significant bit, and this is 0, the least significant bit. So this is RA0 over here, and this is RA7. So, but we said already that these are inputs, so none of these will come on. So none of that. So these ones will drive high, and these ones will drive low. So these 2 LEDs will come on. Ooh, on the test I should put a picture and not only ask like how many LEDs will come on, but which ones. Everybody understand that? Any questions on that one? You all understand. See, you guys are either all geniuses or are going to get 100% on the test because you're not asking any questions. That's just evil. Yeah, so what Michael's suggestion was, if the LEDs were hooked up the other way, right? Now they're reverse biased. If you have a 1 here, so you got 3.3 volts, because it's reverse biased, there would be no current flow, so no LEDs would come on, even if you energize the ports. And here you have 0 volts on either side, so there'd be no current flow. So these would be 0 volts, and these would be 3.3 volts, and so no lights would come on in that situation. Number 4, what are the C language reserved words to create an 8-bit unsigned variable? The C words are an unsigned char. I would have also accepted char because it is implied in C when you say char, it's unsigned. Or US8, which is the macro that we created that's in the Mount Sac C type that allows us when we're writing our codes to not have to try to go, wait, was this 8-bit or 16-bit? We just know it's an unsigned 8-bit variable. And number 5, in the pictured drawing, which side of the LED is connected to the microcontroller, anode or cathode? Number 5 has a microcontroller pin and hooked up to an LED to ground. And it says which side is connected to the microcontroller. This is the microcontroller up here, and the anode is this side, and the cathode. So the right answer is anode. The anode is connected. If the output voltage, number 6 here, if the output voltage of the microcontroller is 3.3 volts and the forward bias of the LED is 1.1 volts, what is the required resistor value to have 22 milliamps flowing through the LED? So number 6, we have 3.3 volts and there's 1.1 volt. The LED forward bias voltage of the LED is 1.1 volts. And we want 22 milliamps flowing through this. So this is a series circuit, so we're going to have 22 milliamps of current flow. The total voltage is 3.3, so the voltage drop across the resistor has to be whatever's left because of Kirchhoff's voltage law, right? All the voltages in the series circuit add up. So you get 2.2 volts dropping across the resistor.
You know the voltage and the current.
Right? Resistance is equal to E divided by I. It's 2.2 volts divided by 22 milliamps, about 100 ohms or something. And I guess this is kind of an electronics 51 question mixed with 50A. You kind of have some experience with diodes, but not really. I mean, this answer really, someone in 50A could answer this question if they understand it. They go, I don't care what this is, I just know there's a voltage drop here and the voltages have to add up to 3. That must mean there's 2.2 left at the resistor.